Okay, welcome to the second half of our lesson 5 on functions, the parent functions transformations. This is part 2. So we've talked about the different parameters in the vertex form, or the transformation form, if you will, which was y equals a times some parent function, f of whatever, x minus h, our horizontal shift, and then plus k, our vertical shift. Now, what I want to do is, in all three cases, you'll notice parabola, parabola, parabola. So in all three cases, I know it's going to be our quadratic parent function. So it's going to be y equals, x something squared. So here's what I want to do. I'm going to take a red pen here, and I'm just going to graph the quadratic parent function. Again, the vertex is at 0, 0, so that right there tells me that we got a problem because it looks like it's moved one left. So I know that this one is going to move left one. There may be more than that going on, but we'll see. Typically, what the parent function for a quadratic does, it'll move left one and up one, left 2 and up 4. And you say, well, why is that? Well, it's because 1 squared is 1, and then 2 squared is 4. And then it's going to have its reflections across the axis. And I'm just going to draw that kind of dotted. So here's what I see. I know it's going to move left 1, so I know I'm going to have a y equals x. And again, since it moved left 1, I'm going to put a plus 1 squared. Now, our next question is there a vertical shift? Did it move like up or down? And no, the vertex stayed right square on that x-axis, so that's not an issue. So is there a change in A? To find out, here's my vertex. Again, normally, like this is a vertex, it goes over 1 and up 1. So I look here, over 1, up 1. Yeah, so technically your A is 1, so if you wanted to write it like that, that would be acceptable, or you could write it like that. You don't need the 1 in front. Okay, next one, I'll write again. Parent function normally starts at 0, 0. This one looks like it goes 2 left and 3 down. So I know I've got a horizontal shift and a vertical shift. So I know I've got y equals, again, 2 left is going to be x plus 2 squared. 3 down is minus 3. So I also see that it has a reflection. So I know it's going to be a negative something. So let's see if it's negative 1, negative 2. So again, normally it goes over 1 and up 1, but since we're reflected, it goes over 1 and down 1. So really it's just y equals negative 1 times the quantity x plus 2 squared minus 3. Now again, if you don't wish to put the 1 in front, you can just get by with just putting a negative like that, and then the 1 is implied. Now, if that was a factor other than 1, which we're about to deal with, then you actually have to write that value of A. So the last one we're going to talk about is this guy. And again, my parent function's normally here. It's now there for my vertex, so I know it goes up 2. And it does not move right or left, just straight up 2. So then I know I'm going to have a y equals a something and then a plus 2. Now, let's look at our graph. Again, normally it goes over 1 and up 1. This goes over 1 and it doesn't go up all the way. It looks like it goes over 1 and then up about a half. But I want to be sure, you know, that it's a half and not like a third or a fourth or something like that. So I'm going to go 2 points away from the vertex. So normally on a parabola, it goes over 1, up 1, or over 2 and up 1, 2, 3, 4. In our case, from the vertex, if I go over 2, it only goes up 2. It's supposed to go over 2, up 4. So it didn't go up that full amount. It only went up half. So this is going to be a 1/2 x squared. If you want, you could actually say 1/2 x minus 0 squared plus 2 because there is no horizontal shift. So, how you feel about that? You feeling better? Okay. Next thing I want to do is I want to take, and if these formulas look really familiar to you, like here, this first one, -3 absolute x, you'll notice it was the first one right here, x squared plus 4. So what I'm showing you is that the ones that we've already written down the transformations for, we got it here. So I'm going to draw the parent function because it does specify that you do that, and it's a good habit to get into. So my parent function is absolute x, so over 1, up 1, over 2, up 2. The parabola is, you know, over 1, up 1, over 2, up 4, but here the absolute value is more like a line. And I'm just going to draw a couple of points. And then I'm going to draw my parent function dotted. Let's pick a different color. And let's do this. So, is there like an H and a K? Is there something in here? So it doesn't move right, it doesn't move down, doesn't move left, doesn't move up. So my vertex stays the same. What's different here is this. Instead of just stating y equals absolute x, you've got a reflection and a stretch. So instead of going over 1 and up 1, it's going to go over 1 and down 3. It's almost like this is like a slope, basically like a 3/1, or in this case, a -3/1. So it is a little narrower than your parent function here. And then also, if you prefer, and I do, I prefer to, instead of saying it gets narrower, I prefer to call it, it's a vertical stretch. Okay, over here, again, my parent function, oh, there's my vertex, over 1, up 1, over 1, up 1, over 2, up 4, over 2, left, up 4, dotted. There's my parent function. Here, I move the vertex up 1, 2, 3, 4. And basically what that's going to do is it's going to move every point up 4. So this one's going to go up 1, 2, 3, 4. 1, 2, 3, 4. And there you have it. Okay, x cubed. That's that weird looking one. It goes over 1, up 1, and then over 1, down 1. When it goes over 2, 2 cubed is 8, so it'll go over 2 and then up 8. So it's going to be something like this, and then over 2, and then down 8. And again, I always like to draw my parent functions dotted so I can tell them apart. And yeah, I mean, the different colors helps too. So here, is there a shift left or right? No. So I wouldn't call it a vertex in this situation because it's really not. It's actually a point of inflection here. So it's going to be here, but I move it down 4, so really it's not there. It's down 1, 2, 3, 4. And then everything else is the same. Over 1, up 1, over 1, down 1, over 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8. Over 2, down 1, 2, well, negative 8. Like down here somewhere. And that's that one. Okay. Next one again, parent function. You should be getting pretty good at doing these now. What's the transformation here? Well, this is going to go left 4. So I move my vertex 4 to the left, and then over 1, up 1, over 1, up 1, over 2, up 4, left 2, up 4. Parent function in red, blue function there. Okay. Square root function, remember it has a domain that starts at 0, 1, 1, 2, comma 1 point something. Here's maybe an easier way. Square root of 4 is 2, so if I go over 4, it goes up 2. So that's my parent function here. And what about my transformations? Well, I believe we said this one is going to go 4 units to the right. So I take this starting point at 0, 0 and move it over here 4 to the right. Over 1, up 1, over 1, 2, 3, 4, up 2. Something like that. Okay, now this one's a little crazier, but that's okay. We can handle it. So again, my absolute value starts at 0, 0. Slope of 1 going to the right, slope of negative 1 going to the left, something like that. And how is this different? Well, it does go down 1, and there is no shift left or right. Now my A is 2, so I have this amplitude or this vertical stretch, which means instead of going over 1 and up 1, it's going to go over 1 and up 2. Over 1 and up 2. So it is going to look narrower or like a vertical stretch. Okay. 3 more like that. Okay, again, this 1/2 for A tells me we're going to have a vertical compression. And then it's going to go 2 units to the right. So, again, basic parent function, 0, 0, over 1, up 1, over 1, up 1, over 2, up 4, left 2, up 4. Parent function. Here, let's start with our new vertex. And our new vertex is now moved 2 to the right of 0, 0. And it's going to go over 1 and up 1/2. Over 1 and up 1/2. So it's going to be pretty wide. Or a vertical compression. Okay, this one, my parent function is the cubic, so 0, 0, 1, 1, 2, 8, -1, -1, -2, -8, and again, that's just cubing in my head. All right. So then now, let's look. So I'm going to go 1 unit to the left and 2 units down. So let's move this 1 left and 2 down. So it's at the point -1, comma -2. That's our new vertex, or in this case, an inflection point. It's got a slope of 3. So instead of going over 1 and up 1, it's going to go over 1 and up 1, 2, 3. Left 1 and down 1, 2, 3. And it's going to be a whole lot steeper, or a more pronounced vertical stretch than the other one. Okay, here we have an absolute value. So 0, 0, over 1, up 1, over 1, up 1. Something like that. And let's talk transformations here. So I'm going 4 up, 2 right. So let's go 2 right and 1, 2, 3, 4 up. So that takes care of my new vertex, or my new starting point. Now here, my A value is -1/3. The negative means we're going to reflect it, and the 1/3 means it's going to look a whole lot wider. So instead of going over 1 and up 1, it's actually going to go down. So over 1, or actually it's going to go down 1 and over 3. Think of this as like a rise over a run. So it's going to go down 1 and over 1, 2, 3, down 1 and 1, 2, 3 the other way. Nice wide parabola. And yeah, on your graphs, I am going to be looking at those like points around it, rather than just seeing somebody just go, something like that. No, I want a little more precision than just that. Because just doing that tells me you probably looked it up on a calculator and you have no clue what you're doing without it. So, 6 last things to do here. I've given you 6 equations, and I've given you 6 graphs. I want to match them up with what they correspond with. So, okay, I can do that. First thing I'm noticing is that I only see one graph or one equation that has a negative value here for A. So basically, to find this one, I'm just going to look for the one that's going downward. There we have it. So this one is C. But again, you can also tell that it's going to go 3 left, 4 down. So 1, 2, 3 left, 4 down. That's the new vertex. And then it's wider, down 1 over 2, which takes care of our half up here also. So C's already done. That helped a little bit. What else do I see? Well, I guess we're looking at, since we already did the ones that are halves, let's take the ones that are, like wider. And these are both 1/2, 1/2. So there's 2 of them that are wider or that are compressed. And A looks like that. And it looks like E also looks like that. So let's look. This one's going to go 3 units left, 4 down. Well, this goes 3 left and 4 up, so that ain't it. This one goes 3 left and 4 down, so E has to match up here which means the 3 left and 4 up is this one. So that matches up with A. Okay. Last 3. I do see they all have, I'll do those in a different color. I do see they all have a vertical stretch of 2, so it's always going to be like over 1, up 2, so they're going to be kind of narrow. They're going to be stretched. What I see, these both have -4s on them, so they're going to go down 4. Of the ones left, this is the only one that's going to be 4 up from 0, 0. So I'm looking for 3 right and 4 up out of what's left. 3 right, 4 up right here. So F is going to belong to this guy. So then what are the differences between my last 2? How do I distinguish between them? Well, let's take a look. They both have the same A value, so they're both vertical stretches. They both have the same -4 for the vertical shift, so they're both going down. But here, this one is going to go to the right 3. This one's going to go to the left 3. So of the ones that are remaining, here's my vertex, or my 0, 0. This one goes right 3 and down 4, which is going to be this one. So that is, whoops, I goofed up here. What did I do? Oh, hold that thought. So yeah, so this one, right 3 and down 4, that's going to be graph D, which leaves us with B for this one. Let's check it out. This should go 3 left and 4 down. So 1, 2, 3, 1, 2, 3, 4. And then over 1, up 2. Yeah, so this one is B. I hope I helped you a little bit here. I hope some of this makes sense. Again, I know you probably covered this in your Algebra 2 class. I wanted to go in a little bit more depth. And again, this is designed to be done without a calculator. I want you to know those transformations. Just by looking at the equation, you should be able to tell what it's going to do. That's the level of skill I need you to have. So with that said, best of luck.